Today's lecture is on Colpitts and Hartley oscillator diagram for a Colpitts and as well as Hartley oscillator where there is an with op amp which has output resistance of R naught and has the gain of AV and VI is the input, and in the frequency selective network or feedback network has three impedance Z1, Z2 and Z3. These Z1 and Z2 and Z3 can have different value depending upon whether they are Colpitts, we want to make it Colpitts or Hartley oscillator. For example, for Colpitts, Z1 and Z2 are capacitor and Z3 are inductor. Now, if we take the feedback network, it will be Z2 in parallel with Z3 and Z1, and we have Vf, which is the feedback voltage. Now we know beta will be equal to Vf upon V naught, and from the circuit feedback network Vf equal to Z1 upon Z1 into V naught upon Z1 plus Z3, or Vf upon V naught equal to Z1 upon Z1 plus Z3. So this is one important equation. Now, from this frequency selected network, equivalent resistance will be Z2 in parallel with Z1 plus Z3, or which is equal to Z2 multiplied with Z1 plus Z3 upon Z1 plus Z2 plus Z3. This is Z equivalent. Z EQ. Simplification of the circuit with op amp, which was AVI voltage source, R output and Z EQ. So the output voltage V output will be Z EQ multiplied with minus AV VI upon Z EQ plus R naught, or V naught upon VI equal to, which is gain A, equal to minus AV Z EQ upon Z EQ plus R naught. This is again an important equation. If we put the value of EQ in it, we will get A equal to minus AV Z2 Z1 plus Z2 upon Z2 in bracket Z1 plus Z2 bracket close plus R naught Z1 plus Z2 plus Z3. A beta, where beta was Z1 upon Z1 plus Z3. Or there was a correction, it should be Z1 plus Z3, not Z1 plus Z2, equal to minus AV Z2 Z1 Z2 Z1 plus Z3 plus R naught Z1 plus Z2 plus Z3. Colpitts oscillator, Z1 is actually capacitor C1, 1 upon J omega C1. Similarly, Z2 will be capacitor C2, which will be 1 upon J omega C2. And Z3 is inductor, so Z3 equal to J omega L. Now we put this value Z1, Z2, Z3 in equation A beta, A V upon J omega R naught bracket minus C2 minus C1 plus omega square L C1 C2 plus omega square L C1 minus 1. And for the sustained oscillator, we know imaginary part should be 0 for the phase change for phase to be 0. So it will be minus C1 minus C2 plus omega square L C1 C2 equal to 0, or omega square equal to 1 upon L C1 C2 upon C1 plus C2 equal to 1 upon L CT, where CT equal to C1 C2 upon C1 plus C2. So resonance frequency will be omega naught equal to 1 by under root LCT. Now we know that if you put the value of omega naught back to the equation, we will get A beta equal to AV upon LC1 multiplied with 1 upon LC1 C2, and C1 plus C2 will go on the top minus 1. As C1 will cancel out LC1, we will get A beta equal to AB C2 upon C1 plus C2 minus C2. C2 will cancel out C2. So A beta equal to AB C2 by C1. You know A beta should be 1. So AB will equal to C1 by C2. Equal to Z1 upon Z3 plus Z1, which we solve will come out to be, on putting the value of Z1 upon Z1 and Z3, it will be 1 upon 1 minus omega square LC1. If we put the value of omega naught into the equation, we will get beta equal to 1 upon 1 minus LC1 multiply with C1 plus C2 upon C1 LC1 C2. LC1 will cancel out L. C2 upon C2 minus C1 minus C2. C2 will cancel out C2. So it will be beta equal to minus C2 by C1. Minus sign indicates there will be 180-degree phase shift. And actually there is a correction in AV. AV should be C1 by C2, not C2 by C1. By mistake I have written AV equal to C2 by C1. So we will get AV will be C1 by C2, beta equal to minus C2 by C1, and omega naught will be 1 by L C T under root, in under root, where Ct is C1 C2 upon C1 plus C2. Now important thing is to note, we know that A was minus AV ZEQ upon ZEQ plus R naught, or ZEQ or ZP, whatever we can say, parallel combination or equivalent. So A will be minus AV ZP upon ZP plus R naught, and we know instead of ZP we can also write GEQ, it is same thing. If R naught is 0, So basically Z2 or Z equal, they will cancel out each other. We will get A equal to AV minus AV. Hartley oscillator, Z1 will be inductor, so it will be J omega L1. Z2 again will be inductor, so it will be J omega L2. And Z3 is capacitor, so it will 1 upon J omega C. Now similarly, we can calculate omega naught, AV, A and beta for Hartley oscillator.